there will be the situation where there are two doctors for a single patient, both are differing in their diagnosis, or there may be agreement between them, between these two doctors, or there can be two examiners and there are, let's say, 40 students. One will say pass, other will say fail. So, how much is the agreement between these two judgment, between two doctors, between two examiners, between two tests? And in this condition, there is nothing like a gold standard. In case of when we are using two tests, statistical tests, at that time we talk about the gold standard. One is a gold standard, other is a not a gold standard. In that case, we go for sensitivity, specificity, etc., etc. But here, two examiners are there, two doctors are there, two judges are there, and they are taking a decision that how many pass, how many fail, or in positive, negative, like this. And in that case, how we use this kappa test, that is what we are going to use. Now, in this case, there are principles, theory behind this, which is a science of probability. For understanding theory, the file is given to you, but for the all practical purpose, what we are doing, that suppose you have two examiners, let's say examiner one and examiner two. So the database will look like this. See, the most important thing when you do the analysis, your Excel file should be such so that there is no uh, beautification. It requires a simple database, and that simple database, I think somebody should mute the mic. Who is speaking? Who is speaking? Anyway, I hope now voice will not be there. So the data, how to design the database is very important. Suppose we have examined 40 students. So serial number and two examiners, name of student, and then examiner one. Looks very simple, but if you have this data, then analysis will be simple. Exam two, examiner two, right? And then one, two, three, four, like this. And examiner one says that you are pass. Two also say yes, pass. And sometimes they say pass, this person says you are fail. Sometimes reverse may be or true. This thing will go on. No, such a 40 students are there. In Excel, you can use the pivot table for the data analysis. That is also possible, or you can use AP info also for the data analysis. And when you have analysis, it will look like this. examiner 2. And here, examiner 1. 1. Says pass pass and fail. Here, fail, pass. Now, suppose totally there are 40 students, and out of that, this fellow says that 30 have passed, 10 failed. Out of this, suppose he says that 20 has passed and 10 failed. And out of this 10, he says 5 passed, 5 failed. If this is the case, here you can have a total 25 and 15. And in this data, you are supposed to find out what is the agreement between the two examiners. There could be the same 40 can be sent for other testing also, other two examiners. That's possible. Now, if you want to find out the agreement between these two examiner, then look at this data 25, 10, 5. Now, in this is this you fill up the data 25, 10, 5. Look at this data. We have entered these four figures 25, 10, 5. And now look at the agreement. Rest of the calculation it is done. You need to just look at the kappa score. It is 0.14. This is the kappa score 0.14. That means the agreement between these two examiner is 0.14. Suppose if you keep it like this 25 and 50, yes 0, yes 0. Then the agreement is 100%. One agreement is one, that means 100. If this is the situation, but if you look at data like this 15, 15, 5, and 5, then you can say it is point where half is agreement, 50% agreement. Now, if you want to understand why this happens, it will take 1 hour. But quickly we'll find out okay, how this agreement principle works. So that those who wants to go for advanced statistics, it is for them only. Otherwise, you can use this test and these data, this analysis, you will get from AP Info. For example, when you go for AP Info, how you get 2 by 2 table? In that, you go for the classic, you go for the RAID file. Here, we are going to learn about how to read Excel file. For the simplicity right now, I am just going to tell you how to go for 2 by 2 table. So we have gone to projects in that sample database so that You will be selecting a database. From that, you will be selecting a table. I think most of you have downloaded the Info. If you have not done it, you should do it. Then only you will be able to learn practically. So we have read the Oswego file in which 75 members were there who went to the party, and then we want to find out 2 by 2 tables. So here you use the tables command. In tables command, examiner 1 versus examiner 2 could be there, but in our case, it is something like chocolate versus illness. Right? Here, how it is 2 by 2 form is prepared. And this data, 25, 22, and 27, this data you need to fill up over here in Excel file. So we'll also learn how to analyze the Excel file in AP Info, but the kappa score is between two examiner, between two doctors. Here you can use the doctor's diagnosis, yes or no. Doctor 2, he says that TB is there, and in few patients say TB is not there. Here, doctor 1 and TB yes and TB no. It could be like this. The number of patients may change. Let's say here it is 30. Here is, let's say, only 3 patients, and or maybe more. Let's say take a 50, and here let's say 2, and here also 2. If this is a situation, in total number of patients, 49. Out of this 49 patients, this is a situation Dr. 2 and Dr. 1. We keep this data in the kappa. If this is a situation, then we can say that Dr. 1, Dr. 2, agreement is 0.81. 81% of the time, there is agreement, and it is a good agreement. This is what you can do. But how this arrives? So kappa, how kappa is calculated? The basic principle is a randomization. Even if you take any 2 person randomly, and even if they are almost similar in their um, let's say education skill, everything, still there is some chances of random error, and that random error is removed. That probability is removed, and then pure the kappa score is taken. Now the PA is agreement score, and this PE is probability of random agreement. So random agreement, you are removing it, and you are also removing from the 1. 1 is 100%. You are removing random agreement from 1 also. And that ratio you are taking, PA agreement minus probability of random agreement. So you will get purely what is a pure agreement, right? Because of the reason you will get. Random, you are removing it. So if it is K is a 0, is a no agreement. If K is 1, is a complete agreement. So this ratio, KP ratio, is calculated. The PA is calculated. Probability of, if you can look at over here, D9 plus E10. D9 plus E10. So this is a D9 and this is E10. 30 plus 15. Those are the agreement. Right? Divided by F11. F11 is a total. Out of 49, what is the agreement? 30 plus 15. So 30 plus 15, 45 divided by 49. So 0.91 is the probability of agreement. Out of that agreement, what is the random agreement, right? That random agreement is L10 plus L11. Here you can see the formula. If you want to learn, here this is the formula L10, L11. So here L10 and L11. This is basically, we suggest that if both says yes and both says no, this probability is there. Here also they have made a total of L6, L8. L6 is this and L8 is this. Making a total, that means it is a both say, that means you multiply. In the sense of probability, when you apply and, you need to multiply. Both says no. You multiply this, you'll get this. Both says no. Now this, when from where this yes is comes, is D11 by F11. D11 is this, by F11 is this. So when say yes, this is for teacher 1, 32 divided by 49, that is the probability over here. And for B, the probability here, F9 upon F11. F9 upon F11. See here what it says that basically probability of saying yes, probability of saying yes over here, and saying no over here and no over here. These probabilities are multiplied. Both says yes and both says no. These total, when you make it, this is a total. And this is a random. And by chance, this will happen. So what it says at kappa, that probability of both the agreement minus random agreement divided by one mass random agreement. So one mass random agreement, it will give you how much can be agreement because of some reason. Out of that, how much actually got it. That will tell you the total kappa. So 90% of the students need not find out this probability, go into that details. But those who want to go advanced, the age, if your age is less than 30 years, you should learn each this sets. And if you find any problem in understanding, we'll come back to you. You need to look at this formula, try to understand this, and then go for finding out the kappa test. I hope that all of you have this file with you. Now, I will write a random number over here, and then I will ask you for the interpretation. You should write the interpretation into chat. If this is the agreement about pass and fail, let's say I need an interpretation. Probably you are able to see the result. If you are not able to see the result, probably now you'll be able to see the result. Now, what does it mean? Teacher 1 and teacher 2, kappa score is probably shown to you, and I expect result. Only, is it a good agreement or less agreement? Just give me one answer, whether it's a good agreement or less agreement, so that I understand whether less agreement. Yes, anyone else? Keep on watching. I think only one person is giving answer. Let me change the data. Now, is a good agreement or less agreement? What do you think? It's very good agreement because now 0.88, right? That was only less. So this is for any number of students, number of tests, two examiner, two doctors, in any such situation, even let's say husband and wife, they are given a choice out of 20, 30 items, whether you choose yes or no, pass or fail, then agreement between husband and wife can be done. The first couple was like this, second couple like, third couple like this. And those agreements can also be listed and we can find out standard everything. So you should understand the base. So you can do this exercise. This file is given to you and you can keep this original one and rest of the thing you can copy paste and can teach others. If possible, start using the kappa test tomorrow onwards and teach few of them. Now we are going for a very good the sampling technique, which just even if you have 10,000, 20,000 people, and by examining only 19 individuals, you will be able to say whether the coverage is good or not. That we are going for that sampling technique. Before I go for that, if you have any question on kappa test, you can ask me. Any question? I hope you are allowed to unmute your mic because once upon a time it was not possible to unmute. Can you unmute? Any question? That is in a chat you can write. Are you able to unmute? No one responding? Okay. No question. Okay, thank you. Now we go for LQS. This file is given to you and you can use it. The name of the file is kappa test kappa E02. Now we are going for the sampling LQS. Now in lots quality assessment, basically this has come from industry. In industry, there is a first lot, second lot, third lot, and they are not actually the testing all the material. They are just taking a few samples from the lots. That's why it is known as lots quality assessment test. In this case, now remember when we are doing this, this will be useful for you to do the sampling technique. And this file is very, very useful for your training purpose and also in actual practice also. Suppose you have a population of, let's say there are 200 villages, you are working in 200 villages or 200 schools, all 200, the 200 colleges, 200 areas, or let's say 100 schools or 100 medical colleges like this. If you are having this units, and from that, if you just draw a 19 symbol, only 19, then also you can talk about the coverage. In coverage, what we mean by over here is suppose it's a vaccine coverage, vaccine given or not. If suppose government is going to give a grant, then the grant was given or not. Or government is going to give a food, whether food was given or not. Is it when there are two options, yes or no. At that time, we can find out coverage was that much or not. Here, you cannot find out exact coverage. That coverage was 65%. This is not possible to calculate, but you can say that whether 65% was there or not. The government says that 75% coverage was there. And just by testing 19 individuals, that beneficiaries only, and you find out of that whether 12 were covered or not, from that you can find out 75% coverage was there. This is a very, very simple and yet very powerful test, and very, but for that sampling technique, you should learn how to do the sampling. In this cumulative population, you need to calculate. But in this file, we have given you the ready-made things. Once we look at this lots quality assessment is completed, then again we will go back to the original of some few minutes if available on test of significance. Otherwise, we'll use AP info again. In this case, let's say that you have list of few villages like this. You have a name of village and population with you, or your name of the school and number of children over there. So this data you can have it, right? Once that is done, what you are supposed to do, that the original file is given to you, and this original file is over here. You can copy the original file, move or copy, here to copy, move to the end. Don't try to use the original file. Original file is kept only for the purpose of the copying. Otherwise, you may uh, get it deleted. This is the batch 626, and we have the data. First, what you should be doing, you remove all this data. First, let's find out how many villages you have. Number two, you have 32, 31 village. You can have 100, 200 village up to that. Now, this is 32. So in this case, beyond that, you don't want to have it. So you can remove those things. Let's say you have removed. You have removed this. And now you're doing a copy paste. This village is also to be removed. Or even you can overlap this, right? This will save a lot of time. You keep one sheet ready in which you have list of villages, list of urban area, list of polio booths, list of schools, list of association, or list of temples, etc. This you do the copy paste, right? You need not touch any other thing. You just do the copy paste, right? Now let's compare the last village is Malpada. in this last village, Malpada. Now, what we are supposed to do now, let me first check any problem in copying and pasting. Clear? Next thing is this is gives you cumulative population. Cumulative population. This is important to learn because in cluster sampling also the same technique is used. And this file will be used for the cluster sampling if you want to select 30 cluster and from each cluster 7 individual, or if you want to select 40 cluster and 6 individual from each cluster getting 240, for that also this is useful. Now once you have this thing with you, what next? When you have cumulative population, use a cumulative sample, this is a sample, right? Now, you need to write down desired sample size over here. You need not touch anything else. Suppose you want to have desired sample size of 19, then you have got everything. This is the first sample, this is another sample, this is another sample. That means you are supposed to select one person from this village, one person from Malpada, not from Bankia Bahal, another person from Tangar Bahal, like this. This gives you from where you are supposed to get the sample. If you change the population, suppose this has a population of 4,000, then you can see that now it has selected two individuals, sample, two individuals from this Subhalaya. Now your study is for giving, let's say, uh, whether the old age people are getting the geriatric care or not. Geriatric care, yes. Geriatric care, no. In that case, you have a choice. If you think that geriatric population is uniform in all these villages, you can still take a total population, find out how many samples to be taken from that village, then you select the geriatric people, 60 years and above. And that selection process is also important, and I will be discussing that also. So, first, let me repeat the things. You are putting copy and paste number of units and population in each unit you will be keeping out of here. You will write sample size. Suppose you need a sample size of 30, it will be different over here. Suppose if your 30 size or sample only you want to take 12, this figure will change and you will get total 12. And that total you can see over here. This is a 12 over here. This is cumulative sample size, and the year is or end is the last village, and the work is over. Rest of the data is only there because if there are more villages, you can use this rest of the thing also, other part. In this case, they have given up to 200, up to 200, 200 villages can be accommodated over here. Now, in this case, in lots quality analysis, from this one we are selecting from this lot of three villages. Another one from next three villages we are selecting. This one we are selecting from one village. This is from another village, like this. This one from three villages. So from each lot, there's decided one like that. Ideally, we'll be going for 19, and that will give a better picture. And we'll see the decision making rule table, because out of 19, suppose your survey says that 10 the old age people were given geriatric care and 9 were not given. This may be your answer. Or in your survey, that could be answer is like this: 17 were given geriatric care, 2 were not given. This 19 will represent the total population. Or if you are taking geriatric, it will represent total geriatric population. This 20,578 from that 19 sample is taken, but it is taken by random selection. Similarly, if you want to select, let's say, 6 individuals from 40 clusters, right? 40 over here, and from each cluster, right? From here you are getting 6, you are getting 2, 2 cluster, 1 cluster, 2 clusters, like this, total 40 cluster. When it is a cluster sampling, 2 means 2 cluster you need to find out, and each cluster you need to define. Each cluster is containing 6 individual or 7. When we decide 30 clusters, at that time from each cluster we are taking 7. I repeat, we are talking about the same formula for loss quality assessment as well as cluster sampling technique. In loss quality assessment, we take an individual selection, while in cluster sampling, we select the whole cluster. So for both the formula, this procedure is the same. Now, let's say we are using for loss quality assessment and we have selected 19 individuals, right? So in that case, you are doing the survey whether the 19 were given or not. There could be different answer. In one city 17 and 2, in another city there could be 5 were given, other city let's say 8 were given geriatric care. So how many of them were covered with geriatric care? That answer could be separate. But once that answer is there, what is the interpretation? And for that interpretation, we have one table, decision rule table. It is known as decision rule table. Let's go for that. And that is also given to you. It is shared with you in a Google Drive. If there is any question, if you are not able to find in the Google Drive, you can let us know. Now, this decision rule table, I will enlarge this so that I think now all of you are able to see this. And this is a point. This decision rule table, first you look the first row. This is a sample size, 12, 13, 14, 18, up to 30. We have selected 19, sample of 19. And suppose out of that, 12 were covered. You see, LQS table, decision rules for sample size of 12 to 30 and coverage benchmarks or average coverage of 10% to 95% coverage benchmarks or average coverage. When out of 19, 12 people were given pediatric care, it means that coverage could be 75%. Coverage could be 75%. Similarly, if 19 is selected and if 13 are covered with geriatric care, we would say that 80% is the coverage. If out of 19, 7, only 7 are covered, we say the coverage is 50%. So this shows the coverage percentage estimated based on this. 7 out of 19 means coverage roughly 50%. Right? Now, why not 20? Why not 18? Because you can see that even if you go for 20, then it does not give you the better result. Even with 19, you get the good results. and that's why we are not going for 20. The purpose of sampling is to minimize the efforts. That is the purpose. That's why we say the 19. But if you want to say, let's say 30, also you can take it. There is no problem in that. But most of the time, loss quality, we are taking 19 because statistically that gives a good result. You need to remember that how many were covered, and that data from this you can find out the coverage. Suppose government says that there is a 90% coverage, 90% coverage. But in this 19 individuals, you could find only 11 were covered. Then you can say that coverage probability that 90% are covered is less because by this survey we can say that 70% is the maximum coverage and not 75, 80, 80, 90 like this. So this is the beauty of this loss quality assessment. So if there's any question, we can discuss that. Otherwise, we'll skip to other topic. Any question? So try to see the loss quality assessment yourself. It gives you that how many could be covered, not beyond that. This type of test of significance will spend only few minutes because it is already talked about, but it's just rushing in 2, 3 minutes. Test is divided into two parts, parametric and non-parametric. And whatever it may be, we find out p-value. P is the probability of event occurring by chance. How much is the chance that it has occurred by chance? Right? P is the probability of event occurring by chance. In parametric test, it follows the normal distribution curve. And because the number is also more, there's a pattern is there. That's why it is more reliable. So when you have enough sample size, 100, 200, 500, at that time, try to go for parametric test rather than the non-parametric test. And also it should be following the normal distribution curve. So t-test, z-test, NOR test are the examples of parametric test. Now, we will see that in non-parametric test, we'll talk about chi-square test, Mann-Whitney U test, Wilcoxon sign rank test, etc. When sample size is very low. In terms of clinician, suppose the physiotherapy is only 10 patients. In surgery, there are only 5 patients or only 12 patients in the gynec. And you want to find out the improvement is there or not before and after. In such cases, we'll be going for non-parametric tests. And whatever is the thing, you always start with null hypothesis. There is no significant differences there. And whatever is occurring by chance. That is what you will be starting with. And then, if the probability of null hypothesis is much less, that P is the probability of null hypothesis being true or probability of occurring event by chance is less than 5%, will reject. Right? So, if P is more than 0.05, more than 5%, we'll accept the null hypothesis. Here is the zone of acceptance plus minus 2 standard deviation, and there is the zone of rejection is beyond this plus minus 2 standard deviation. The p-value, if it is beyond, is much less because this is a zone of acceptance by chance distribution. If it is away from that, less chance that it is a part of chance distribution. So that's significant. So how to use, when to use non-parameters, when to use parameters, that will be looking at example the next time. And before we end, at least every time I repeat info for a few minutes so that you can start using it. If you have not downloaded it, you should. This is a file epinfo 7, which is already given to you in a Google Drive. If it is not available, just send me the email at rajesh4health@gmail.com. I will send you the zip file and you can use it. Just unzip and use these two files just like this in your desktop. You launch the epinfo 7. You can use the classic. The video is already shared to you so that you can follow the steps. Read command, browse. Now, in this case, if you want to use the Excel file, instead of epinfo project file 7, you should be writing XLX file. If you select this and browse, you can select your Excel file. Next time we'll be using Excel file. Right now we're using project file. Browse means you find out where your project is. All the projects in epinfo in project file and sample file is given for you to practice. And in manual, they have given details of data analysis of different kinds. You go for Oswego file. 75 records are selected. And here, if you write frequency, you select frequency of what? Mashed potato. How many took mashed potato? Yes or no? It will give a frequency. If you go for tables command, it will give like this. Coffee versus, let's say, mashed potato. Is there any significance between two? Those who are choosing this or that, and you will find the p-value. Yes, there is a significant p-value is less than 0.0. That means that those who are going to take the coffee, those people are more likely to take most the mashed potato. If those who are not taking coffee, they are less likely to go for mashed potato. So there's a relation between taking coffee and mashed potato, and this is a significant reason. So this kind of the interpretation you can find out. And is there a different significant difference between coffee and age? Mean of age versus coffee. So there was difference was there, whether significant we'll see later on. Yes, the mean age was 46, not taking mean age was 29. This difference, coffee versus age, if you look at the p-value, it is 0.00041. Here F test is used, NO is used, and it is 0.0041. It's a significant difference. Older people, they prefer more coffee compared to the younger people. This is how we can use app info. We have seen frequency command, tables command, and means command. Now the session is open for question answer. If there's no question, we'll stop here. But I prefer if you have questions, that will be much better. We need not worry about whether 5 people are there or 7 people are there. If you have any question, you can ask. I will tell you what we are going to learn next time. We'll be using standard error next time. We'll be talking about standard error of proportion, standard of mean, standard of difference between two proportions, standard of difference to mean. These four things we will be doing, and how to use the standard deviation to find out the area under the curve. These are the certain things which are the basic principle in a test of significance that we'll be learning in next time. And you are already given the whole folder with you. and that you should be going through that. And some of the examples will tell you. And if your Excel file is ready, if you send me by email, I will show you how to do the analysis of Excel file. Otherwise, I will keep one Excel file ready, and how to use AP info for Excel file, that will be looking at. I stop here, awaiting question, else I will close. Open, have you understood anything?